Our first speaker to kick us off in this first return to in-person BSides Las Vegas is someone you probably know way better than me. He's someone many of you have probably had announce the changes of your careers and your lives. Ladies and gentlemen, please welcome Chris Hoff, or Beaker, to the stage.
Good morning. I thought I got out of this with the speaker not working, but unfortunately it is. Can you guys hear me okay with this Bane mask on? Yeah. All right, fabulous. Let's see if this can get this to work.
Started the fire.
All right, cool. So they asked me for an abstract for this talk, which is what the line underneath Fragilience is. I took a word cloud of words out of my presentation and threw it at them, so it actually means nothing. The title, Fragilience, is a mashup of two words, fragile and resistant and resilience. And there are a couple of takeaways that I'd like to establish up front about what this talk is about and why I'm here and what I want you to take away from it. The first is I have not been able to publicly speak in 7 years. That's what happens when you get subsumed by a risk-averse financial institution. So not only is it BSides back, but I'm very thankful and grateful that I get to come up and talk to folks and have ultimately a set of discussions after this. The second thing is there's a bunch of points in this talk that I think will come hopefully into cognition as we run through it, but it's about 5 different talks crammed into one, so I'm making up for missed time. When I think about InfoSec, there's a lot more art and compliance than there is science today. When we do make use of science, and I use that term broadly, it's often very siloed. We aren't very organized in terms of how we take advantage of science. We don't define, model, or manage risk well at all. We are not agile, and our definition of resilience varies, and it is insufficient. This word resilience is sort of critical to this conversation. Instead of resilient, and some of you may moan or groan when you hear this term, but we ought to be anti-fragile. And anti-fragile is an interesting topic that I'm going to get into in this talk because it talks about both the past, the present, and the future of where information security is headed. And hopefully the thought process is here. I don't pretend to be right. What I do hope is that we start a set of conversations to get people to recognize that things aren't quite as bad as people make them out to be, number one, and we have an awful lot more at our disposal than most people actually recognize. So with that, this is not one of those grumpy, oh my God, InfoSec is broken talks, although it sounded like it from the introduction. But what it is a discussion about words. So there's a bunch of words that get used interchangeably these days: secure or security, resilience, robust, survivable, recoverable, defensible, certain, sustainable. Resilience has become the new buzzword of our industry. A lot of it is because of the types of attacks and the outcomes that have happened. So when you look at things like supply chain attacks, nation states, when you look at what we're seeing with ransomware, no longer is it about being secure, it's about being resilient. And the definition of resilient is interesting. If you look at what NIST defines, the government agency ultimately that defines a lot of things for us and standards that we use. These words are important. The ability to anticipate, withstand, recover from, and adapt to bad things from happening. The stuff on the left, which will be hard to read, but I'll give you all these slides later, it just talks about the context. So are you talking about network security, nation state, are you talking about critical infrastructure, applications, people, etc.? The table on the right, which ultimately came from Accenture, was about goals and outcomes from the perspective of performance characteristics of what happens if you do resilience well. So if you look at that chart, you'll see, if you are more resilient, you will stop more attacks, you will find breaches faster, you will fix breaches faster, and you will reduce breach impact. But the challenge with what is meant by resilience came to a head for me about, well, not me, this fictional guy we'll call Chris, in let's say a financial institution about 5 years ago. Showed up, Chris did, to this regulator meeting where they were talking about a horizontal across these GSIFIs, which are these globally significant financial institutions, systemic financial institutions. There are 8 of them in the United States, by the way. They're not publicly named, but you can probably guess who they are. And the question that they ran through this in terms of scenario modeling was, listen, we understand what you do from a security program perspective. We understand all the controls you have, et cetera. We want you to assume that all of your controls have failed and you are a smoldering pile of rubble and you have to rebuild and recover and restore. And they looked at me and they said, what do you do? And I said, besides the normal sort of cliche, update my resume and crack open that bottle of bourbon, was I don't do a lot. I'm an InfoSec. Besides securing the environment in which the owners of applications and services would restore, I don't do much. And they said, well, who does? And I said, the application service owners in IT. And they turned, and I watched this imaginary turret turn towards them. And they said, okay, so out of all of the app and critical service owners, purportedly, in this bank, who's the most important? And they all raised their hands. And they said, okay, we're going to pick one. Payments. Okay, payments. Who's the owner? Me, this guy says. And he goes, which one of the subcomponent services do you get back up and running? And of course, there's 200 of them, and he couldn't really answer the question. That kicked off a set of, purportedly, these things called MRAs, matters requiring attention, across all these banks that talked about you're doing resilience wrong. Which means you need to be able to recover, rebuild within these service level agreements to make sure there aren't impacts to the public. At the same time, in the FRB, that was the US base, the Bank of England was talking about, no, resilience means you should never go down in the first place. So if you look at what we talked about, right, anticipate, withstand, recover from, and adapt to adverse conditions, the definition by itself, even with regulators today, that drives a lot of what people do in terms of their security programs is out of date. And the challenge is that if we don't understand that word, and it's supposed to be the next evolution of security, how do we even know what we're aiming for? So a couple of years ago, whether you're a fan of him or not, Nicholas Taleb came out with a book titled The Black Swan. And Black Swan events are events that in the middle of things, in the fog of war, that you could not anticipate ever happening. But in hindsight, you're like, oh shit, yeah, of course. We could have seen that, we could have prevented that. Great examples, the reason we're wearing masks. Pandemic, 9/11, for example. The interesting thing is, in hindsight, planes crashed into buildings like the Empire State Building. We've seen methods, but the motive and opportunity and outcomes are very different. So in hindsight, you look at a black swan event as something you can't really predict. And ultimately, the outcome is largely greater than, instead of being proportional with the event itself. And so hindsight is a very interesting part of that conversation, because Taleb went on to write a book called Anti-Fragile. And what he stated in that book was the primary part of what is the definition of anti-fragility, which is that some things benefit from shocks. They get better. They don't just recover. Human bones are a great example. You break a bone, your bones actually calcify and become stronger than they were in the first place. So anti-fragility, which is a huge part of the conversation we're going to have, is about getting better in the face of stressors, not just remaining the same. And that you can visualize that by looking at this graph. Ultimately, if gain and benefit is the y-axis and stress and change is the x-axis, normally what you'll see when people use the word fragile is it's a concave response to stress. You break and you don't get better. If you look at ultimately resistance or robustness, which is a natural response, you resist, you get a little bit better for time, but then you go back to being how you were. Ultimately, if you look at resilient, you recover and you get better for a while, or you improve for a while, but then you ultimately go back doing what you want. The key here is that anti-fragility is convex in response. You get better consistently, right? You actually not only just learn, but you become stronger from the stressor. So if you look at how anti-fragility is more interestingly defined, on the right you have this notion of disorder, volatility, and randomness, and your responses to them. So on the side of being agile and anti-fragile, you ultimately embrace change and you gain or benefit from it. You ultimately get better, you absorb shock and get better in the face of stressors. Trigger word, security, is ultimately all the way to the left in the most part, which is we try to get to at least a base level that we feel comfortable with. We don't like change. Ultimately, we don't adapt very well. We resist change, if you think about controls, and you basically stay the same. Not that we don't learn and ultimately incrementally get better, but we don't fundamentally change. The system itself does not get stronger. So with that, the notion here is if you start thinking about what that means to our practice and our industry, you could posit that InfoSec is actually fragile. But without sounding like that's a terrible negative thing, there's a lot of opportunity there. And in fact, those opportunities have come from decades of work that have been done in the past. So there was a paper written in 1999 that was titled Information Survivability. And it basically talked about how the world was changing. And on the left, you can see, for example, systems are centrally networked and under organizational controls. They will transition to systems that are globally networked with distributed control, right? The internet, and without barfing things like Web3. You can go down this list and really understand that at the bottom of it, it talked about that today security is seen as an overhead or an expense versus survivability as an investment and essential to the organization, and that technology IT-based solutions have to become enterprise-wide and risk-based. Now we look at that today and we go, well, that makes a total bunch of sense. In 1999, that was sort of heresy. But the people that wrote this thought about what it meant in the evolution from both secure to survivable to anti-fragile. And one of the challenges that when I looked at why we don't or can't or have a difficult time getting better, it's we seem to conflate these tactical information frameworks, sort of the what, with this set of guidelines and playbooks that are linear in action, chains, the how, with decision systems for complex system problems that actually tell us about the why, when, and who. Now, that may not make a lot of sense in one slide, but let me clarify that. Today, if you look at this sort of spectrum of sensors, sense-making, decision systems, and levers and actuators, we have an enormous amount of sensors. Take whatever you want in terms of instrumentation or observability and define it that way, and they're shotgunned across the stack. We have many different sense-making capabilities, lots of consoles, lots of ways of single panes of glass that ultimately allow you to visualize what you're seeing. We tend to skip decision systems that allow us to make decisions on risk and instead head straight towards, with the application of some level of automation, these levers and actuators, right? And you'll note the words on the top, you'll see them again later: probe and sense, categorize and analyze, weigh and decide, and act and respond. Now, I'll say, having run large-scale security operations teams, being able to have the time and luxury to make decisions in the fog of war is a very difficult thing. But a lot of that has to do with the velocity, the volume, and the quality of the data we capture in the first place. And we're going to get into that in a little bit, because we're going to focus on the fact that the reason I posit that we are largely fragile and not anti-fragile is that we don't take time to invest in decision systems to actually make risk-based decisions. In fact, just the opposite. This is just a small sampling from a company, a reseller called Optiv, and these are the products that they sell. There are literally thousands upon thousands of sensors, sense-making, and levers and actuators you can buy today, and each of them claim to be open and integrated, et cetera, but the reality is none of them really feed into a methodology that lets you make a decision. So with that being the case, just an illustration, I went through and I sort of did a quick inventory of a lot of different inventory of systems, from IT asset management to graph-based functionality in clouds to vulnerability management platforms, you name it. There's tons and tons of different ways we can think about visualizing the data we get from sensors. We have a linear sort of view in Lockheed Martin's cyber kill chain that says that, well, this is the methodology by which every adversary basically enacts his or her craft. And it's always linear, when in fact we know it's not. In many cases, it's iterative. We have great tools like MITRE ATT&CK, which allows us to talk about and categorize the knowledge base of adversary tactics, which lets us think about how adversaries may indeed be looking at exploiting us. We have cool things like detect and attack flow, and I think Gabe Bassett's giving a talk on attack flow later, which allows you to visualize and map your defenses against attack to know how well sorted you are against a particular adversary, and then actually even visualize it. So go look at Gabe's, go attend Gabe's talk on attack flow later. Interestingly, we have the NIST cybersecurity framework, which again says you should identify, protect, detect, respond, and recover, and it's always linear, but it's not. In fact, you go back and forth a lot of times. We have Sunil Yu's cyber defense matrix, which takes the inventory of NIST from the perspective of those categories and maps them across domains and lets you visualize where you have clusters of technology and or human-based responses to these particular sets of threats, and allows you to understand where you're weak. You will notice that in most cases, if you were to map this in your environment, you would have very few things in the respond and recover, or at least in the recover category, because it's mostly people-focused. We have great things in the vein of threat modeling. We've got structured processes to do this. We have Pick your favorite model, Stride, Dread, Pasta, you name it. So we have all the capability to essentially be able to document how systems ought to work. We have Dave Bianco's pyramid of pain and the effects and outcomes in terms of how we could degrade, deny, destroy, or otherwise disrupt adversaries based on the availability or unavailability of certain IOCs. We even have amazing VAR model-based frameworks for doing quantitative-based risk management and risk assessment. What that really means is you're able to get to and express dollars of risk based on the probability and frequency and magnitude of loss, and actually attribute dollar amounts to what a particular event could bring you. So I just shotgunned you and firehosed you with an enormous amount of stuff we have, and you would say, well, if that's the case, then why can't we make good decisions quickly? And a lot of that would be answered by these four guys. So Dave Snowden, not related to Edward Snowden, Jens Rasmussen, Nicholas Taleb, and Simon Wardley. Incredibly smart people. I only share two things with them, which is a receding hairline and graying of the beard, but I am fans of their work. And we're going to cover some of these in a second in a very rapid fire way, because I want you to think about tools and whether you're even thinking about using these tools. So Simon Wardley built this process, and he open sourced it, called Wardley Maps. And it's a way of mapping strategy. A lot of people use it for business, but you can literally use it to map anything. And it basically uses a bunch of doctrines and rules to allow you to understand, based on a customer or user's needs chain, a set of needs and dependencies and components. What that allows you to do is make really interesting decisions in a relatively short period of time. Now, there's a statement that says all maps are wrong and some are useful. And this is a true statement because it is a very, we'll call it personal thing, a map. Now, maps are good if you know where you are. If you don't know where you are, it's very hard to know, even if you know where you're going, how you're going to get there, right? So that's where mapping comes into play. This particular map was open sourced and published on the web. It was a team that was looking at the executive management as a decision maker or customer with drivers like regulatory compliance. They need to prevent breaches, detect breaches, and manage breaches. And they took those components over a level, over an x-axis of maturity of the component. And that chain, if you follow like regulatory compliance, depends on having automated control monitoring. But that particular component, from genesis to custom to product to commodity, means that some of that stuff, as they grouped it here, would have to be delivered in-house because it is not available to be able to just buy. You have to build. Other stuff, in their view, was more commoditized. It became more product-oriented. So you see things like vulnerability scanning or attack monitoring. So mapping like this gives you a view. If you take like Sunil's cybersecurity defense matrix, and you say, I have all these capabilities and tools, not all of them I'm able to harness, not all of them I'm able to harness myself. How can I map those and make use of them in my environment to make better decisions? Mr. Snowden is famous for something called the Conoven Framework, and it's a Welsh word, which is why it sounds nothing like what it's spelled like, just like Cymru. And basically what he says is it's a decision fabric that is based on 4 different domains: simple, complicated, complex, and chaotic. And in simple, what you ultimately have is a bunch of known knowns. And so you apply best practices. You sense, you categorize, you respond. Complicated, you sense, analyze, and respond because there's a bunch of known unknowns, things that you know that you don't know. Complex is a bunch of unknown unknowns, like you just absolutely don't understand the space, but you're able to sort of probe, sense, and then respond. And then chaotic is where you ultimately are unknowable unknowns. Really think about that black swan events I was talking about, and you act, sense, and respond. The interesting thing about that is it's a maturity of where you are in the space that you're analyzing. If you apply this to InfoSec, we tend to have a binary view here of looking at things as either being simple or complex, where I would argue that the majority of things are more complicated, simple and chaotic, where I would argue that in many cases, the majority of stuff is more complicated and complex. And the reason that's important is if you're trying to make decisions about things, especially in the InfoSec space, you have to understand the space in which you are actually afforded good quality data. So if you apply this to like the history of our aeronautics, in the beginning, it was very chaotic. Somebody said, we ought to be able to fly, we don't know how, and we don't know what stuff looks like. There were weird designs with flapping wings and corkscrews and a whole bunch of other stuff. And people tried and iterated and failed a lot. Right? They made good decisions by just trying things out. Complex, after the Wright brothers made a plane that had wings, a propeller, and a tail, people sort of knew you could fly. It was a good and reasonably safe plane. But then to make planes better, they had to ultimately iterate and test what was already there. Years passed, you got to the complicated realm where now you had longer and more complex problems like overseas travel, which brought a whole new set of challenges or problems to the table. I need to make decisions on isolated cabins, fuselage equipment, fuel-efficient jet engines, need to be cost-effective. So in that particular space and complicated, you had to analyze hundreds of materials, designs, and test them to make sure that they actually worked. Today, in the simple realm, we already know how to fly. There's not a lot of magic. Like for the most part, unless you're optimizing for a particular trait like speed or longevity or potentially outer space travel, for example, if somebody needed to buy a plane, to build a plane today, you could pretty much take all the existing knowledge and apply it. Now that's important. I got lazy and ran out of time. I was going to do one for InfoSec, but you could map this to any one of the domains. You could talk about perimeter security, data security, you name it. And what you would find is that in many cases, the decisions, the data that you have would indicate that you would make different decisions. And what's interesting about that is there's another field, parallel field of study called safety science and human factors. There's a guy named Jens Rasmussen. He died in about 2018, but he talked about 4 different themes that emerged in his work. And this is the part that in InfoSec we tend to leave out a lot. And you can all let out a collective groan about users, and if we only didn't have users, security would be easy, right? And at the end of the day, most of the stuff that we impose in terms of controls is to prevent users from doing bad things. We tell them not to click on stuff, we tell them not to do stuff. Well, what he actually said is that for example, industrial scenarios like nuclear power, there are 4 things that you have to think about. Human operated performance results from behavior, and you can actually identify and model behavior, which is something we don't do a lot of. Human operators flexible and adaptive. They compensate for shortcomings. They cope with complexity by applying mental models using this skills, rules, and knowledge-based system that he archetyped. And then risk management requires an understanding of all of the inputs and outputs. And so the whole point about this is it brings in another definition of resilience called cognitive resilience, which is it implies a practitioner's scope or a user or a person's ability to cope with unexpected events. So whether you're in security or you're a particular user, we count a lot on people making good decisions, which is a challenge. So, by the way, who's seen Soylent Green, the movie with Charlton Heston? All the old people. Yeah. So it was set in 2022, by the way, which is the irony is not lost on me. So what do we have to do to apply all this stuff in InfoSec? So there's a really interesting talk that Mario Plot gave recently on how do we apply safety, and I thought about safety, and you'll see some like I Am the Cavalry and a bunch of stuff that Josh Corman and team have done around medical devices in the same way, thinking about how we make sure that devices are safe and high quality. But there are really different ways you can think about applying different strategies based on the domain that you're in. And I use this big, giant, muddled mess to say, look, if you have a threat actor, and we have threat models, and we have ultimately situational context by using Snowden's mapping, you take into consideration human factors, you map this stuff out, you can apply your models. Ultimately, what you get to is a way of being able to apply stuff that we have today, but make decisions in a more formulaic way. Now, this looks complex, and it will be decades in the making. And so what I want you to take away from that is there's a much more simpler view of what this means to InfoSec. And John Lambert did a great job of actually summarizing this somewhat orthogonally in one of his talks, where he talked about advancing InfoSec towards an open, shareable, contributor-friendly model of speeding InfoSec learning. Because everything I just talked about is about learning about your environment. So if you look at the left, he said traditional defenders defend a list of assets, manage incidents, minimize risk by keeping incidents secret, view pen tests as a report card, and think about stopping attacks. He implied that modern defenders defend a graph of assets. Right? You also heard defenders think in lists, attackers think in graphs, same concept. We manage adversaries, we maximize learning by sharing incidents with trusted outside peers. We view pen tests as an input, to get better. And we think about the increasing the attacker's cost and time in order to attack us. So this is a little bit more simpler to grasp, because if you look at how we've applied those rules and all that muck that I talked about in the beginning without even knowing what we were doing, today you see a lot of structures and organizations of security teams looking very, very differently than they were before. We're seeing diffused and embedded security teams, especially in places that build product. You literally have embedded security team members that aren't part of some big collective Borg in the middle that is called InfoSec. We've seen the proliferation of continuous integration, continuous deployment, and now continuous service as we integrate security tooling into our dev tool chains. Cloud and site reliability engineering have really brought a lot of the practices I just talked about secure by design and secure by operation into fold. We've seen the emergence of whole new sort of subspecies of capabilities that we've put new names on, like observability and detection engineering crop up, which is about where we lay in that sensors, sense-making decision systems timeline. We've seen robust and threat risk modeling start to take shape, where people are doing this stuff more religiously. Chaos engineering has entered the chat, and we start thinking about monkeys and the simian army and turning things off and on and looking at and adopting cloud design paradigms like you saw with AWS when they came out a decade and a half ago with design for fail, which is, by the way, antithetical to what we do in security. And we've seen the emergence of a book, and if you haven't seen it, you should all run out and get it, in my opinion. It's called Team Topologies. It's about how you organize technology teams to really optimize what you deliver and how. So we're going to cover off that in a little bit. By the way, my little timer is not running. What's the time? 9:55. 9:55. Oh, fantastic. All right. I'll slow down a little bit. All right. So Wendy Nather, the goddess of all goodness in security, came up with a term about 11 years ago, called this cybersecurity poverty line. The visualization may not be accurate, but it's good for effect, right? Where she said basically, big companies can afford more people in technology. And there was a line, the cybersecurity poverty line, where many of us are afflicted by the fact that we can't. And so how are we supposed to defend things when we don't have the budget and people to do it? A lot of this is not because we don't have the information or skills, but ultimately that poverty line is real. So we have to be able to think about how we structure and organize what we do without having to depend on spending more money or building more people. And a lot of that harken back to the conversations that we were having, or the statements I made about automation in the past. But Dino Daizovi, and I don't expect you to read this, I'll hit the high points, at his keynote at Black Hat 2018 said, look, software teams need to own their own security now, and security teams need to become full stack software teams. Let's sink in for a second, right? Basically what that means is, from a security perspective, we need to be able to deploy security code, and we need to be able to inject ourselves into the frameworks and methodologies that developers use. He also went on to say that security teams will become internal security software teams that deliver value to internal teams through self-service platform and tools. Now, for those of you that look at that and go, that sounds great, what many of you have interpreted that to mean is we should just call ourselves now DevSecOps teams, because instead of being on-prem, we've moved to the cloud. Mario Platt did another great talk where he said, and he ultimately captured a bunch of input from the intertubes that said, if your notion or strategy mentions the word DevSecOps and you're not understanding how the governance teams need to deal with what that means, and thus regulators, you're not really doing DevSecOps. If you're not increasing the agency and ownership of security across those that own the product, you're not doing DevSecOps. If you're not enabling the best possible out of developers and engineers, you're not. And all you've done is essentially rebranded yourself to look like you are relevant. And in fact, there's a quote down on the bottom from Kelly Shortridge, who has lots of spicy and snarky takes on a lot of stuff. And what she basically said was, DevSecOps is something that most security teams think they can run out and buy to make themselves seem more relevant. Now that seems sort of a little bit gruff and in some cases wrong, but in many cases, just because you read it on the internet doesn't mean that it's true. And how many of you have been in conversations where the words site reliability engineering have come up in a conversation, and SRE is now something that some manager says that you ought to go do without really knowing what it means? And in fact, harking back to discussions that you might have around how it was implemented at Google, SRE is not used in every software team. It's very expensive, it's very onerous. And ultimately, is it a right design principle and a destination to aim for? Sure, but in the same way that DevSecOps or DevOps in that particular case means a lot of things to a lot of people, simply calling yourself DevSecOps does not actually get you towards being more anti-fragile. In fact, the problem becomes even more interesting. There's a law called Conway's Law that basically says for any organization that designs systems, you ship your org chart. And what's funny about the pictures you see there, like Amazon, Google, Microsoft, or the funniest one is Oracle, where engineering's this big and legal is this big, right? The reality is they ship their org chart, and the usability of the products really do reflect how the software developers and security teams are organized. And that little graph from Microsoft on the right that indicates how you ought to structure your InfoSec team is incredibly complex, right? So we are essentially applying Conway's law to security when the org and engineering teams and business teams look completely different from how we're organized. So there's this thing called the Reverse Conway Law, which allows you to basically say you really ought to organize yourself differently. There's this notion of team topologies. I'm not going to get into it in detail, but if you haven't read the book, again, I suggest you do. It talks about 4 different types of topologies: stream-aligned, enabling, complicated, and platform teams. They do different things. They provide different services. They consume different services. And ultimately, they have different ways of working with each other. So you've got collaborative models, X as a service, and facilitation. And just really quick, take that for what it is. I pulled down an example that Docker has implemented in what they call building stronger, happier engineering teams with team topologies. And what they had on the left were very sort of monolithic teams, where if you were building something like the Docker Hub, what you might end up doing is you would have sort of a bunch of a subordinate team that does UI, middleware, backend, and that team is responsible for that particular product, and they would have to ultimately jockey for time, money, and resources to be able to get their product done. And there's a lot of shared code. There's a lot of ambiguity as to who owns what. So in the model that they ultimately applied, their new structure was one where they organized their development teams writ large. Everybody responsible for example, in the growth category, which would be account growth, the account growth team, or a particular product like Docker Hub, had everybody they needed to be able to bring that product to market, including ultimately security teams. They build these team APIs that describe exactly what each team does and how they interact. And why that's important is, if you take it to the next level, and this next slide is something I added onto, because they alluded to it, but they didn't include it in their slides. If you think about that from a security model, there's this notion of a complicated or X as a service set of core capabilities that aren't necessarily engineering centric. So that would be like GRC, incident response, incident response and management, maybe even vulnerability management, that provides a set of services with embedded security engineers in each of the product teams. What that gives you is a much more focused, close to the business way of thinking about, from a decisions perspective, what decisions you ought to be able to make to bring that product to market securely. There are a number of models that exist, for example, in large finance and other industries, where the security teams are massively monolithic or they are very distributed. Where ultimately the individual teams are empowered to do what they want. But what Team Topologies has done is started to be able to align how security teams function with the business and the engineers that are doing it. And Dino and I were having a conversation along with other people the other day, and he said, wow, it's almost like if technology isn't all built by one monolithic org, then we shouldn't have technology secured by one monolithic org either. And that's a great summary of what that means. So organizationally, that also sort of, and I know Corman's probably here, and I put this in here because he yelled at me, he's over there, the last time that I didn't mention this in response to resilience, but I don't know, 8 years ago, maybe more, okay, maybe even more than that. The Rugged Manifesto was really aimed at developers, but it talked about how you should take this mindset of being rugged in software development, which ultimately the important part's down at the bottom. It's not a technology process model, secure development lifecycle, organizational structure. It's not even a noun. It's not the same as secure. This is a way of essentially applying these rules to be able to think more holistically, and it really does rub off on what I talked about with Jan Rasmussen's safety talk about things like, this is the way we function, this is the set of services, and this is the ethos by which we implement more secure code. Security is a byproduct of being rugged, right? Which rugged is another word for resilient, secure, survivable, etc., or in this case, anti-fragile. So you may be in the audience and you're like, well, I don't work for a company that develops software. It doesn't matter. The same things apply. You consume it. And so the way in which you think of applying these concepts apply whether or not you develop software or not. Now, you also may not be in a position where you can change the org structure, but you can think atomically about how you ultimately deliver services. And part of the problem that I wanted to bring up is that, you know, security has a leadership dinosaur problem, and we're waiting for the meteorite to hit, right? So most of the people that manage and lead security teams today in larger established companies are old like me. Now, we came up from a time that was much more complicated and or chaotic, in as much as security didn't necessarily exist with all the frameworks, governance, and tools. Many of us were network administrators or system administrators. And when the internet came online, we started doing security stuff, and here we are. But we've ultimately been doing the same stuff over and over again. That's starting to change as you see new leadership and new blood, and a lot of the younger folks in the audience, as you come up, the availability of thought processes and tooling and knowledge sharing, these events didn't really exist the same way they do today when we were coming up. So leadership is an issue. Organizational culture is another one. The notion of security being a control function and not an enabler. At the same point in time, I sort of Ralph every time I hear somebody say security should be a business enabler. It should be, but in the context of how you organize is important. And the culture we have is very punitive. There's a lot of noise and not a lot of signal. We get drowned with an awful lot from that sensing, sense-making, and lack of decision systems issue of cognitive load. The outcomes are really about, let's just not be any worse than we were yesterday, not how do we get better. We have a very punitive incentive model, right? Instead of stick versus carrot or broccoli versus ice cream, a lot of what we talk about with developers, what you can't do, not what you can do. And language is a problem. So from the perspective of how militarized our industry is, just look at words like DMZ and pen testing. I mean, if you go into an environment with people that aren't security people, I mean, many of us have gotten on the plane on our way here with our disobey and DEFCON backpacks and strange piercing and Wi-Fi devices, and we sort of look weird to people. We're not particularly accessible. I mean, in many cases, we have over-militarized what it is we do, which makes it very difficult to communicate in easy terms. I mean, somebody in my org one day said, Jesus, we're saving passwords, not lives. Not unfair. So what does this mean? Listen, at the end of the day, we have an awful lot of stuff at our disposal. We have a lot of data. We have a lot of tools. We have a lot of technology. But we have ultimately relied more on art and compliance as the way in which we operate versus science. A lot of what we do is siloed. Places like this are fantastic because we get to share what we do. We get to share our successes and our failures. We can think differently about how we're organizing, and larger companies will have a trickle-down effect on all of us as they display success in organizing differently and operating security differently. We cannot continue to simply be the department of no. I know we've heard that a lot, but a lot of the capabilities that we have really means that at the end of the day, being resilient, meaning being no worse than we were, being able to bounce back but not actually learn from and get better is not sufficient. And we really need to be more anti-fragile. And again, that means getting better from stressors and adverse events. So that was my hope that I had in combining 5 talks into one and probably annoying the crap out of you with buzzwords. I wanted to communicate. And at the end of the day, I don't think anybody said it better than Dan Gear, which is up on the screen. Work like hell, share all you know, abide by your handshake, and have fun. We can do all of that at the same time as we make better decisions by being less fragile and more anti-fragile. This was not a talk meant to even have a punctuation point. It was meant to spur a set of conversations and discussions and perhaps research in a lot of those strategies and things that I talked about. Jens Rasmussen's approach to safety, Snowden's view of decision-making systems, et cetera. And if I have time, I'll take questions as best I can, but the point was I was hoping to spur a conversation, not end with a big bang. So I don't think I ended with a big bang, so at least I got 1 out of 2. But yeah, you had a question.
It's not so much a question, an observation. We should take a look at the automobile industry.
Yep, automobile industry.
They acknowledged early on that the car wasn't important. They designed cocoa zones to protect what was important, the people inside the
Yep.
car. So that when the accident happens, and it might not be your fault, it might be your fault, it doesn't really matter, the occupants of the automobile survive and walk away.
Right.
We need to start engineering our security programs in exactly the
Agreed.
same way. But get the frickin' assets, then not to...
Yes. Let me replay that real quick for people in the audience. He basically is making a parallel to the automobile industry and their advancement of safety and safety science over time. And they invented things like seat belts, or actually gave them away, and crumple zones in the automobile, which is meant to protect the asset in case of an accident. And ultimately, we need to do the same. It sort of ties into a lot of what Jens Rasmussen said. But a lot of that is being thoughtful about being rugged, about being anti-fragile in the way in which we think about outcomes differently, which is not just, I stopped this particular event from occurring. What impact or outcomes did it not have that adversely affected the org? Yeah, thank you for that. It was a good summary. All right. Yeah.
Unlike the automobile industry, maybe we should also be concerned about the people outside of the car.
Oh, that's an interesting one. Unlike the automobile industry, perhaps we should be concerned with people outside the car. Well, my wife's FSD Tesla is certainly an indicator of that. She's hit numerous curbs, luckily no people, but yeah, I do think that the system as a whole, if you look at Snowden's thing about, right, the environment as a whole is a very important piece, not just people we protect, but unintended consequences. And if you need me to go, you can just give me the hook. I'll just keep talking to them one at a time. All right. Anyway, I hope that was helpful. Thanks for bearing with me. I haven't talked in 7 years, so I'm a lot out of practice. Thanks.